Good morning, class. Good morning, class. My name is Ido, and today we'll be discussing on geometrical progression. In our previous class, we discussed about arithmetic progression, but in this class, we talk about geometrical progression. Now, what do you know about geometric progression? Let's look at this series, this sequence. 3, 6, 12, 24, 48. If you notice something about this sequence, that's difference. It does not have a difference. That's a ratio. In an arithmetical progression, we have what is called common difference. Look at this. 1, 2, 3, 4, 5. If you notice, that's a difference of what? A common difference of 1. But when we are dealing with a geometrical progression, we have what is called common ratio. Now, this is a what? This is the first term of a sequence. Let's call it A1. Then the second term of the sequence, A2, third term, A3, A4. Now, the difference between a geometrical sequence and an arithmetic sequence is that in a geometric sequence, we have what is called the common ratio. Let's look at this. 3 times 2 give us what? 6, which is the second term. To get the third term, 6 times 2 is equal to what? 12, and so on and so forth. Now, you will notice one thing. We are multiplying by what? By 2, which is the common ratio. So our R, in this case, the R here is what? Is 2. Now, in the geometrical, let's talk about what is called. Now, let's deal with questions. Question under. Now, let's look at it. We have R equals 2. So the common ratio of in this case is what? Is 2. Now let's talk about what is called geometric mean. We have arithmetic mean and we have geometric mean. Now look at this. The formula for the geometric mean. Is what? Square root of what? A dot B. Now what is this? What is the meaning of what? Square root of A dot B. Now if you are asked, let us calculate the geometric mean of 3 and 12. How can we get that? Just simply geometric mean is the square root of what? 3 times 12. And 3 times 12 will give us what? 36. So we have the square root of what? Square root of 36, which is equal to what? 6, which is the middle term here. You get it now? So we have what? We have geometric mean, which is what? Which is 6. Now, in a geometrical progression, if you're asked to get the value of the nth term, you're asked to get what is the value of the nth term of the geometrical progression, it's given by this formula. An, meaning that we don't know the number of terms. An is what? AR raised to the power what? N minus 1. The A here is the what? Is the first term of your what? Of the geometrical progression. The R here is your common ratio. Then we have the N. We asked to calculate the number of terms. We have the N raised to the power N minus what? Minus 1. Now, using the same sequence, let's calculate let's calculate the 10th term of this sequence. We are asked this question. Find the 10th term of this sequence. We are asked to find the 10th term of this sequence. We have what? We have our A known. So we write A subscript 10, which is for the 10th term of this sequence, is equals to, we know our first term to be what? To be 3, multiplied by, what is the ratio? The ratio is what? The common ratio is 2, raised to power what? 10 minus 1. So now we have what? 3 multiply 2 raised to power what? 3 raised to power 9. If you 2 to the 9th time, you get your answer, then you multiply it by 3. Let's do it. Let's do that. 2 to the. So we have our answer to be what? 1,536. So that tells us that what? The 10th term of this sequence is what? It's 1,536. Now, let's move to the last part. We have what is called sum of what? Sum of geometrical sequence. Now, this is a what? This is a sequence, Abby. Now, a series is just the what? The addition of what? Of this sequence. Now, we are asked, this is a what? This is a geometrical series. This is what is called a geometrical series. This is what is called a geometrical sequence. Now, if you are asked, find the sum of this geometrical series. Find the sum of the 10th term of this geometrical series, which is what is given by this formula. Sn a open bracket r raised to power n minus 1 over what? R minus 1. So this is the formula we use if you are asked to calculate the sum of the geometrical series. The sum of the geometrical series. Now, remember I told you, we are asked to calculate the sum of the what? 10th term of this series. We have what? Sn equals, now as usual, A here signify what? The first term. You have your what? UE, open brackets. R here signify the what? The common ratio. So then raised to power n, we ask for the what? The 10th term of the sequence. So raised to power 10, then minus 1 over r here is what? 2 minus 1. Do we get it now? So now we have to calculate the sum of the 10th term. We simply write. We have to calculate the sum of the nth term. Simply have 3 into brackets 10 raised to power 2 raised to power 10 minus 1 all over 2 minus 1. Now, what is 2 raised to power 10? Let's do that. We have what? 1,024. We have 1,024. So you simply 3 into brackets 1,024 minus 1 all over what? All over 1. And we all know you have your denominator to be 1. It's simply this. So we have what? 3 multiplied by what? 1,023. So I have my answer to be what? To be 3,069. 3,069. So this is simply the what? The sum of the what? The sum of the 10th term of this series. Sum of the 10th term of this series. Now, mind you, you use this formula if your what? If your R is greater than 1. If your R is greater than 1, use this formula. You get it now? If your common ratio is greater than 1, use this formula. But if your common ratio is less than 1, you can also use this formula. 1 minus R raised to power n over 1 minus R, or R less than 1. Now, you can't have R equals to 1 because this denominator will be what? 0. And whenever you have a number divided by 0, it gives us what? Infinity. So in this case, if you have R greater than 1, you use this formula. If you have R less than 1, you use this formula. Now let's deal with some questions. Now, let me tell you one thing. Your geometrical series, you have what is called what? The common ratio, not common difference. In arithmetic series, the pattern is what? Addition and subtraction. But in your geometrical series, the pattern is what? Multiplication and what? And division, which signify the R here, which is your what? Your common ratio. Now let's deal with questions. Let's deal with some questions. Now let's open to Now, let's look at our UTME past question year 2006 to 2010. Let's look at question 6. Now, remember, some of the nth term of the geometrical series is a open bracket what r is power n minus 1 over r minus 1. But what? R greater than 1. Then a open bracket what 1 minus r is power n over 1 minus r for what? R less than 1. Now let's look at question 6. The second and the fifth term of a geometric progression are 21 and 567. That tells us what? We have been told the second term and the fifth term. Now let's use this formula. We use the formula of what? A raised to power n equals what? A raised to power r n minus 1. Why am I using this formula? I'm not asked for the sum of the term. I'm only told the nth term, which is what? In this case, the second and the fifth term. If you are asked the sum of the second term, then we can use this formula here. So now, in this case, we are told what? We are told A2 is what? A raised to power what? R raised to power what? 2 minus 1. Do you get it now? 2 is your what? N. So you have raised to power 2 minus 1, which is what? A R. Then we are also told the fifth term, which is A5, equals what? A R raised to power 5 minus 1, which is your A raised to power 4. You get it now? Now we are told the second term is equal to what? 21. And we are told the fifth term is equal to what? 567. Now the question asks you, find the first term and the common ratio. Find the first term and the common ratio, the value. Now, how can we get this? You simply divide. Do you get it now? We do a subscript 5, which is the fifth term, and the second term is equal to what? A raised to power AR raised to power 4 over what? AR. Now, which is equal to what? 567 divided by what? 21. Now we can see we can cancel out our A. Will be left with what? R raised to power 4 over what? R raised over R. Now, if you do this, R raised to power 4. Remember, the R raised to power 1 is also the same thing as what? R. So we are dividing, which is what? 4 minus 1. If you use your law of indices, is equal to what? 567 over 20 over 21. So we are left to what? R cubed equals what? What is 567 divided by 21? Let's do that. 567 divided by 21. We are getting the answer is what? The answer is 27. So if you cube both sides, let's cube both sides. So we have what? We are left with R is equal to what? 3. The cube root of 27 is what? Simply 3. Now we've gotten the common ratio. Now let's get the first term. Now, since you know the common ratio, you can pick either one of these two to get your first term. I can pick this AR equals 21. Since I know what my R is, I can easily get A. Or I pick this one and I can also get my what? We get the same answer. So let's use this first one. AR equals what? Equals 21. So now we are given R. We have what? 8 multiplied by what? 3 equals what? 21. So your A is simply was 21 divided by 3, which was 7. Now, which is what? Which is option B. We have our first term to be what? 3, and the common ratio to be what? To be our first term to be 7, and our common ratio to be what? To be 3. So that's it for the first question. So whenever you are asked to calculate the geometrical progression, we look at we should know the formula to use. We treat a second question on that. So the second question, let's look at our past question 2012 to 2013. Question number 50. Question number 50. Now, question number 50. Let's remove this one. Now let's look at question number 50. The second and the fifth term of the geometrical progression are 6 and minus 48 respectively. The first term is, we are asked for the first term. This looks similar to the first question we treated. So we are asked to calculate the first term. Now we are given the what? We are given the second term. So that tells us what? Tells us what the second term of the progression is what? What is a raised to power what? N minus 1. And in this case, it says a raised to power what? 1, which is AR, which is equals to what? Which is equals to 6. Now let's do the second question. I have what? A raised to power what? A subscript what? A subscript 5, which is also the fifth term, which is a raised to power what? AR raised to power 4. And that is what? That's negative 48. Just like you treated the last one, you divide your fifth term by your what? Your second term. So I have what? A raised to power AR raised to power 4 over what? AR is equal to what? Negative 48 over what? Over 6. So I'm left with what? A raised to power 3, which is what? Negative 48 over 6 is what? This is what? That's 8. So now we are left with what? A raised to power 3 equals what? Negative 48. So now we do the cube root. Negative 8. Let's do the cube root. So I have what? Let's confirm this. Now, as you can see, there's a fault with this question. You can't have the cube root of a negative number to give us a complex number. So that automatically makes that question wrong. So let's look at another question. Let's look at UTME year 2015/2016. Let's look at 2015/2016. Let's look at number 7. Let's look at number 7. This is a new number. Question number 7. Now we are given in a geometrical progression. The geometric progression, the first term is what? Is 153. So that tells us what? A is equal to what? 153. Now the sixth term, A, the sixth term is what? Is what? A raised to power what? 6 minus 1, which is what? AR raised to power what? 5. It's giving us what? It's giving us 17 over 27. So we are asked to find the sum of the first 4 terms. The sum of the first 4 terms. That tells us what? We are using either one of these two. We are using either one of these two. Sum of the first 4 terms. Now, how can we get the sum of the first 4 terms? We need to guess what? Our R. Because for us to apply this formula, we need to know the value of R. We already know our A to be what? 153. And we know the N to be what? To be 4. So we ask the first 4 terms. But now, how can we get our R? We know A to be what? 153. R raised to power what? R raised to power 5 is equal to what? 17 over 27. Divide both sides by 153. We are left with what? AR raised to power 5 equals to 17 over 27 times what? Times 1 over 153. So AR raised to power 5. That's what? That will give us. That will give us 1 over what? 243. So now what we do, we take the fifth root, take the fifth root of both sides. We are left with what? R equals what? 1 over what? 2, 4, 3. So now let's get our R. The fifth root of 1 over 243. The fifth root of 1 over 243 is what? Simply 1 over 3. So that tells us what? Our R is less than 1. So we apply what? We apply this formula. So now we ask for the what? For the fourth root. The sum of the what? The first 4 terms, right? We ask for the first form of the first 4 terms. So that tells us what? S4. Now we are using this formula. S4 equals what? What is the A? A is what? 153, 153. Open brackets, what? 1 minus our R is what? 1 over 3 raised to power what? Raised to power 4. 1 over 3 raised to power 4. Then over 1 minus what? 1 over 3. Now that tells us what? 153, 1 minus. Now let's press our calculator. 1. So I have 1 minus 1 here. Then over what? 2 over 3. So if we press the calculator, 153 in brackets what? 1 minus 1 over 1 over 51. Then 2 over 3. We are given the answer here is what? 680. 680, sorry, 680 over 3. So this is the sum of the what? The first 4 terms. That tells us that what? If you add the first time 153, the first term, plus what? The next term, plus the next term, plus the next term, 4 terms, this is what we get. So that tells us that's option B. Option B, 680 over what? Over 3. I hope you all get it. So now, from this three questions we've done so far, I would like to ask you guys if you have any questions to ask. So you guys will be unmuted very soon. So you can ask your question, starting from the beginning with what we've done so far. So let the questions come in.
So you are shorting the working.
Okay. Can see it now. So remember, you can ask your question. Let this class be interactive. What we've done so far, anyone you have issue with, if it's the sum of the first 4 terms, if it's the nth term of the geometrical series, you can ask your question. Let's do that. Which parts do you have issue with? I'm listening. I'm listening. Before we take one more example, let's ask which other part do you have issue with?
Good morning.
Good morning.
My question is that if we are given like let's say, question that says if there are like 4 progressions, like how are we going to represent it? Like the way you did A equals 15. I can't really see the board well, sha. So how are we going to represent it like that? That's my only issue.
Okay, if you are given A subscript 4, I'll be the first term.
Yeah, like we are given a question now. So how are we going to represent it the way you did?
Okay, like if you are given a question, just like the one I did earlier, if you are given a question, they will tell you the first term of a sequence of a series is 153. You always know your first term is represented with what? With A. So you write your A equals 153. That's the first part of the question. Do you get it now? Now the next part told you that what the sixth term of the series is what? The sixth term of the series is 17/27. Now I represent my sixth term of the series to be what? A subscript C. In some textbooks, you see it as what? TN. Doesn't matter. They are still talking about what? The sixth term of the series. Do you get it now? So your sixth term of the series using the formula A raised to power what? N minus 1. So originally, you know, it's just what? A raised to power what? 5. Then is equals to what? 17/27. Now the question asks you, calculate the sum of the what? The first 4 terms. You get it now? Calculate the sum of the first 4 terms. So if you represent what you are given in the question with these values, A equals what? 153. A raised to power 5 equals this. So originally, you know that you can't calculate the what? The sum of the first 4 terms. You don't know your what? Your R. Do you get it now? If you don't know what
Yeah.
your R is, you can't calculate the sum of the first 4 terms. So you can always try to get your R from this what? From the information given. In every questions in your past question, there will be some information given for you to get the next step. So in this case, I told you we need to get the R, and the R, by the time you calculate it, you have your what? 1/3. You get it now? R to be what? 1/3. So using this formula, using this R into this formula, you'll be able to get your what? S4. Do you get it now? So in every
Yeah.
question, you'll be given what will help you to get the next step. Do you get it now?
Yeah.
Do you get it
Thank you.
now?
Yes.
Okay.
Thank you so much.
So now my question, my issue now is that I want you guys to know the difference between S4 and TN or T6. Do you get it now? So you should have what is called sum of the n term, and you should have the n term itself. So let's do one more question. Now, this as for this question, your 2019/2020. Now, if you look at this question number 15, find the 8th term of the following geometric progression. Find the 8th term of the following geometric progression. So now we are given the geometric progression. We are given the geometric sequence to be what? To be 1, 2, 4, 8, and 16. That means it goes on and on. So we are asked to what? To find the what? The 8th term. So that tells us we can't use these 2 formulas here, because these 2 formulas is dealing with the sum. But this one is just asking for the what? The 8th term. So it is what that signify what? A was subscript 8, Abby. That asks for the what? The 8th term. And now what's the formula? You have what? ARM minus 1, which tells us what? AR8 minus 1. Do you get it now? AR raised to power what? 8 minus 1, which is simply what? AR raised to power what? 7. Now, AR raised to the power 7, what is A? A is just your first term. In this case, the first term here is what? 1. So that's just what? 1 multiplied by what? What is the common ratio? Now, remember, I told you earlier, whenever you are dealing with geometrical sequence, you have what is called what? Common ratio. Unlike your AP, your arithmetic progression, where you have what's called what? Common difference. So now in this case, what is your R? Your R is simply what? A2 divided by what? A1. Do we get it now? Your common ratio R is what? A2 divided by A1, or you have what? A3 divided by A2, or what? A4 divided by what? A3. You still have the same answer. It's just what? 2 divided by 1, which is what? 2. So your common ratio in this case is just 2 raised to the power what? 7. If you pick this, 8 divided by 4, you also have what? 2. 16 divided by 8, you also have what? 2. So your 2 raised to the power 7 give us what?
128.
28, exactly. That's 128. So our answer now is what? 128. That tells us that what? The 8th term. This is your first term, second term, third term, fourth term, fifth term. The 8th term of this sequence is what? 128, which is what? Which is option D, 128. So do we get it now? Now, also, you might also come across this question: calculate the geometric mean. If you remember the formula for your geometric mean, your geometric mean is simply what? Square root of what? A dot B. Do you get it now? Find your geometric mean. You'll be given the sequence. So if you're asked to find your geometric mean, like now, find your geometric mean, just simply what? A dot B, then the square root. So that's all.
Sir, the geometric mean, please.
Yeah, geometric mean.
What was B?
The B can be any value from the sequence. You get it now? A dot B indicated. Find the geometric mean. Like, can we get questions on that geometric mean? Let's get questions on that geometric mean. So the time has almost run out. It has almost run out. So about the geometric mean, we solve more questions on that geometric mean in the next class. So we can't do that now, but in the next class, we solve more questions on geometric mean. But I hope you guys, you understand what we've done so far. You understood the sum of sequence and everything. So that's what we'll be doing for today. Thank you very much for listening.